So again, now chapter 5, Consumer and Industrial Chemistry, 5.2, Cleaning Agents. What is soap? Soap is potassium or sodium fatty acid salt produced from the neutralization between the fatty acid and alkalis, okay, the carboxylic acid and the alkalis. Fatty acid can be obtained from natural esters such as animal fats and vegetable oils. The picture here shows some soap in our country. The Dettol one, the Sunlight, and the Dynamo. Those are the product. Okay, we have general formula here. Um, this is the general formula for soap. Okay, RCOON. R is the hydrocarbon chain contain carbon and hydrogen. So the R actually is the longer, and R is just a short version on writing. Okay, but in the real answering questions or in the real chemistry, it should be carbon and hydrogen, a longer chain. Now this is the functional group. Okay, remember the fish. This is the mouth of the fish. Okay, the fish actually have the H because the fatty acid, carboxylic acid. Now the H has been gone and the place is taken by the sodium ion. So COONA. So RCOONA is the general formula for the soap. And some soap have the K at the front. So Na is sodium ion and K is the potassium ion. So this is the common general formula for soap. We have two types, okay? So R is an alkyl group, long chain carboxylic acid within 12 to 18 carbon atoms per molecule. So it can be saturated or unsaturated. Is determined by the double bond in the R, okay? If the molecule have the double bond, so it will become the unsaturated. If the double bonds doesn't exist, it will become saturated. Okay, we have example of soap here. We have two examples. The first one is sodium laureth. Chemical formula is CH3 and CH2 in the bracket is 10 molecules. Okay, so you can imagine how long the molecule it is. COO and ACE. This is the functional group. So fatty acid, the fatty acid is lauric acid, come from the fatty acid of lauric acid. You can see here it's still attached to the hydrogen. When the hydrogen will kick out, the sodium will take the hydrogen place. So the source for lauric acid is coconut oil. The second one is sodium palmitate. Yes, the CH2 is 14 molecule in the bracket. Okay, so the fatty acid should be palmitic acid. The source is palm oil. From the words, the name, we know that this type of soap come from the palm oil. Okay, example of soap, we have sodium palmitate, the second one. So this is the longest continuous chain. Okay, the carbon and hydrogen, the R. Okay, so it written by this type of statement: CH3, CH2, 14, COO, and A. This is the functional group. Detergent, a non-soap cleaning agent made from the synthetic source of petrol, which is petroleum fraction. It is a sodium salts of sulfonic acid. Sulfonic. So the element in the acid, the biggest one we are going to state is sulfur. Here is the sulfur. There are two types of sulfonic acid used to make detergent. The first one is alkyl sulfonic acid. Just see the formula SOOOOH. So the sulfur will circulate by the oxygen. Just remember the structure, and we have H here, and alkyl benzene sulfonic acid. So both molecule is the carboxylic acid, but different for alkyl benzene. We have those bolt and nut here. The hexagon, is it hexagon? Mak nak pergi bandar petang, yes, hexagon. Benzene, those hexagon actually is the benzene. So we just draw like this, but actually the benzene should be look like this, carbon and hydrogen. There are 3 double bond inside the benzene. Okay, you just, I mean, just see the molecule, okay? See the molecule. There are two general groups of detergent. The first one is sodium alkyl sulfate, and the second one is sodium alkyl benzene sulfonate. Okay, sulfate because it contains sulfur here, yeah? Sulfonate, sulfur here. So example of structural formula, the R again actually is the long chain of carbon and hydrogen, and this is the functional group, the S surrounded by the oxygen and Na. And same goes to the sodium alkyl benzene. The R actually is the long carbon chain with the hydrogen just beside each carbon. And we have sulfur surrounded by only 3 oxygen. And at the end is the sodium ion. It's just you see the structure. Okay, watch and learn the structure. That's all. Okay, preparation of soap. The process to prepare the soap, we call it as saponification. Please memorize the spelling, the pronunciation, saponification. Prepared through hydrolysis of oils or fats in sodium hydroxide or potassium hydroxide. That's why each soap, I give you two examples of soap, contain an A plus and K. It depends on their alkali when react with the fatty acid. Okay, it produces a fatty acid, carboxylic acid, sorry. It produces glycerol and fatty acid salts. So the soap actually is the fatty acid salt. So general equation, the oil or fat will react with the concentrated alkali to produce soap and glycerol. Glycerol is the alcohol. Soap is the fatty acid, carboxylic acid. So in saponification, actually you are break the bond between the fat is ester. Okay, this is the reverse reaction in esterification, if you can connect between esterification and saponification. Okay, saponification, this is the chemical equation for saponification reaction. Here we have the oil or fat molecules, so we call this as the ester. This is the ester actually. Oil and fat are ester. So here is the functional group COO, 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 and R is the hydrocarbon chain. I mean, this is the sodium hydroxide, the alkali, and here it will produce a glycerol. Okay, reaction between the alkali with the oil, it will produce the glycerol is alcohol, and another one is the soap. Okay, as we see here, we can find that we have 3 molecules of soap. The R1, R2, R3 are long chain hydrocarbon. It may be the same or different, and the functional group is at the end, which is COO and A. Why Na? Because we use sodium hydroxide. If we use the potassium hydroxide, the end of the soap molecule will be potassium. Okay. Preparation of detergent made from petroleum fraction and sulfuric acid, which is H2SO4, two process to produce detergent, which is the first one is sulfonation and neutralization. Okay, here I would like to show you two different detergent, which is sodium alkyl benzene sulfonate for the first one, and both process, which is the sulfonation and neutralization, are occur for each type of detergent. Now we go to the first one. This is the sulfonation reaction first. This is the alkyl benzene. Why benzene? Because we have the bolt and nut here. Okay, because we have benzene here. Okay, react with the sulfuric acid and the OH from the sulfuric acid. Okay, sulfuric acid H2SO4 will react with the hydrogen to form water, and the place where the OH and the H gone will combine to produce alkyl benzene sulfonic acid. Okay, then the alkyl benzene sulfonic acid here bring it to the second reaction, which is neutralization. Reaction between sodium hydroxide and the H acid. Of course, it have H plus. The H plus and OH minus will react to produce water. Then the sodium will combine with the O. Here is the place where the sodium combine. Now we have the detergent called sodium alkyl benzene sulfonate. The second one, preparation of sodium alkyl sulfonate. Okay, sulfate, that is sulfonate. Okay, sulfonation of alcohol. So sulfonation is the process where we put the sulfur into the alcohol. Okay, this is the sulfur from the sulfuric acid. And again, we have a long chain alcohol. Okay, alcohol react with the sulfuric acid, and again OH minus and the H plus from the alcohol, the H from the alcohol react to produce water, and the place will combine to each other and produce alkyl hydrogen sulfate. Okay, this is sulfate. Okay, and the same molecule bring it to the second reaction where the neutralization occur when alkyl hydrogen sulfate react with the sodium hydroxide, and again we produce water as the byproduct or the side product, and the sodium will goes and attach to the oxygen here. Okay, now we have sodium alkyl sulfate. Do you know how to make soap from used cooking oil? Okay, we are going to do this next week. Okay. Cleansing action of soap and detergent. Soap and detergent act as emulsifying agent which is soluble in oil or grease. So soap in detergent is dissolved in water to form sodium ion or potassium ion. The second one is soap anion or detergent anion. For your information, when soap goes into water, it will divide into two sections, which is the first one is the anion and the second one is the sodium ion. Okay, the sodium ion will goes into the water, while the detergent also separated into two different parts, which is the first one is the detergent anion, anion meaning the negatively charged, yeah, and the sodium ion will goes into the water. The positive charge, the positive part of the soap and detergent will separate it from the anion. Okay, structure of soap and detergent anion. There are two parts with which is the first one is the hydrophilic. Philic. What did you remember when I say Felix the cat? It is a cartoon where the Felix means sayang, okay, love. Maksudnya this part sayang hydro. Hydro is water. So hydrophilic is sayang air. So this part is soluble in water. And the second one, hydrophobic, come from the word phobia. Phobia takut. Takut apa? Takut air. So hydrophobic, this part will soluble into oil or grease because they are takut air. So goes into the oil or grease. Okay. This is the hydrophobic part, the rantai panjang. Sorry. The long chain of carbon and hydrogen, we call it as hydrophobic. While the functional group at the front, we call it as hydrophilic. So which part will goes into the grease? Yes, the hydrophobic part. When they're afraid of hydro which is water, they goes into the oils. And same goes with the detergent. The longest chain of hydrocarbon is, we call it as hydrophobic part, and the heat, it's not the heat, the functional group at the front, we call it as hydrophilic part. Hydrophilic, hydrophobic. You have to familiar with the terms. Okay. Now we go to cleansing action of soap and detergents. Oh, now we go to the Dobby shop. Adding soap or detergent into water will reduce the surface tension of water. This increases the water's ability to wet the surface of the clothes. Sometimes when we wet our clothes, the water cannot penetrate at the thread between the cloth. Why? Because the water itself has a surface tension. That's why the ayak-ayak or the air or I think that insect on top of water can move around on the water surface. So by adding detergents or soap, the water surface tension has been reduced. Then the water can go and penetrate in between the cloth, the thread between the cloth. Okay. Next one, the soap or detergent will ionize in water. Ionize meaning separated between the positive part and the negative part. Okay, so the positive part are swimming around in the water, but the negative part with the long chain hydrocarbon will goes into the grease. Okay, separated first in the second step. Now the hydrophilic parts, hydrophilic, the longest chain of soap anions or detergent anion dissolved in the water. Okay, then the hydrophobic part, the hydrophobic yang takut air tadi, will goes into the grease, oils, the kari mamak here. Okay, so movement of water during scrubbing and agitation causes grease to pull away from the surface of the clothes. Kalau zaman dulu apa campak kain batu sungai, macam itulah gambarannya. Or in the washing machine, the process of swirling, process of goes into there, and here it's a process where the grease going to pull away from the surface of the cloth. Okay, the hydrophilic part of soap anions or detergent anions surround the grease. The grease will float to the surface of the water. The grease will break into small droplets. The small droplets will not reattach to the surface of the cloth due to the repulsions of the negatively charged of the hydrophilic parts on the surface of the grease. Okay, they will repel each other. Nyah, kau dari sini. Nyah, nyah. Jauh, jauh, jauh. Dia cakap lah. Rinsing, bilas, with water causes the surface of the clothes to become clean because the grease droplets are left in the water. So how the dry cleaning process were done? Dry cleaning meaning without the water. This diagram shows you how the dry cleaning process. This is just addition information for you. The clothes go in dry and come out dry, but are submerged in a liquid solvent called perchloroethylene during the process. So they're using an organic solvent, for example, perchloroethylene or 111 trichloroethane. I think 111 trichloroethane is easier molecule to draw, maybe. Yeah, ethane, just 2 carbon. Special stains such as lipstick or paint are pre-treated by the cleaner. Oh, we have the dry cleaning machine. So this machine will okay. Clothes go to the drying machine. Program type of fabric and colors. Those is shine and liquid solvent soak into the cloth. It can remove dirt and humidity in the cloth. As in a consumer machine, the clothes are agitated and rubbing action remove the stains. Oh, it is important. After 30 minutes, the spin cycle drains the solvent. Oh, just to drain the solvent, it just need a heat because the solvent can easily vaporize with a higher temperature, in a higher temperature. The clothes now are dry. Clothes removed to be pressed and hang. Okay, so this is how the dry cleaning were done. Comparison of cleansing action of soap and detergent. Hot water, meaning a water that containing calcium ions, which is Ca2 plus, and magnesium ion, Mg2 plus. This is the definition of hot water. You have to memorize it. Contain calcium ion and magnesium ion. Okay. Soap and ion combine with the cations to form insoluble salt. So those insoluble salt, we call it as scum. So the soap's cleansing action is not effective. Okay. So the clothes cannot be clean in hot water if we using soap. This is soap story. So this equation shows how the scum will form. Scum is insoluble salt. Okay, so when stearate ion, okay, from the soap react with the calcium ion, the calcium ion already waiting in the hot water, okay, it will produce calcium stearate, which is the scum. And another stearate ion, which is from the soap, react with the magnesium ion, also already in the water, which is the hot water. It will produce magnesium stearate, which is the scum. Okay. Detergent anion also combine with the cation to form a soluble salt. This story is about detergent. The previous one is about soap. Okay. The detergent will combine with the cation, which is the magnesium ion and calcium ion, but it will produce a soluble salt. Okay, soluble, not insoluble salt, the soluble salt. Detergent anion, we have S here, S to show it is detergent, react with the calcium ion or magnesium ion. It will produce calcium salt and magnesium salt. Those salt is soluble salt. That's why in hot water, detergent can work very efficiently. So we have one experiment to prove this situation. Okay, effectiveness of cleansing action of soap and detergent. Do read, and we are going to do it next week. Comparison of effectiveness of cleansing action of soap and detergent. Okay, So this is soap, this is the detergent, this is the aspect. So soap is effective as cleansing agent. Detergent is also effective as cleansing agent in soft water. Soft water. Soft water is ordinary water without containing magnesium ion and calcium ion. Now in hot water, soap is less effective due to the formation of scum. Detergent, it is more effective because no scum is formed. Okay. In acidic water, soap not effective due to the formation of insoluble organic acid. Detergent effective because the organic acid form is soluble. Okay, we have lots of additive in detergent. Okay, some of them biological enzyme function to remove protein stains such as blood, milk, and sugar. Example, we have amylase, protease, cellulase, and lipase. Whitening agent to change dirt to colorless substance. For example, we have sodium perborate and sodium hypochlorite. I think you need to memorize some of the example. Okay, sometimes the question asks you to state the examples. Okay, optical whitener to make clothes become whiter and brighter. Example, we have fluorescent dyes. Water softener and builder to enhance the effectiveness of detergent by softening the water. Yeah. Example, we have sodium tripolyphosphate. Foam control agent. Tak bagus ke foam? To control the foam. If we produce more foam, more water is needed to clear the foam. So by adding foam control agent, you can save the usage of water. Example, we have alkyl monoethane, ethane, ethanolamide, monoethanolamide. Okay. Anti-suspension agent to prevent the removed dirt from redepositing to the cloth, to make sure all the dirt goes out, doesn't attach to the cloth anymore. So example, we have sodium carboxyl methyl cellulose. Fragrance to enhance the fragrance of the detergent and fabric. Example, we have jasmine, lavender, but I prefer the lemon, maybe the lemon, the citrus fruits. Drying agent to ensure the detergent powder is always dry in its container. I think this one special for the powder form of detergent. Okay, so example, we have sodium sulfate and sodium silicate. Oh, that's the end of part 5.2, cleaning agent. Thank you.